Hello guys, Nokia at this side. So today we are going to solve this problem, largest number formed from an array. I hope you have already read the problem and have tried by yours. So in this problem, we are actually given an array as a string of arrays, sorry, an array of strings, and we need to perform a rearrange of these elements. And after rearranging, we just need to concatenate in them on order and check and tell the maximum result we can get. So I can rearrange in any way. I can put 330 together, then I can put 5 here, then I can take 34, and then I take 9. By rearranging them, we need to find the largest number we can form. So since we need the largest, so we will look for something lexicographically largest because 9 is our largest number. So something starting from 9. If I have take 9, then I will check what is another what is after 9, which is smaller than 9, but lexicographically larger than the rest of them. So in this case, 9, we have actually 5. I can put 5 here. Now it will say 34, it will say 30, and then it will say 3. So do it yield us the greater result? We get 303, but actually we need 330. But majority of the things are same. So this is making us very clear, like because we need to yield the greater number. And since string sort in lexicographically order only, so if I tend to sort in reverse lexicographical order, so I might have yield a greater string. And that is very true for this case, but just last some digits. If I look at this example, here also 60 is bigger, we get 60. Then we have 548 because 547, 548, 8 is lexicographical larger than 6. Then we will come at 546, and then we got 54. So 548, 546, 54, this is as a great result just by sorting. So somehow sorting in lexicographically reverse order is correct. Just we need to make sure how we actually do that. Instead of 303, we get 30. We get 330. We need this, but we are actually getting this. So when our sort method actually working, it's perform comparison. It's actually perform comparison, and it's check if A is less than B, then put A first, then B. I'm saying when I am sorting it in terms of increasing order. So actually internally it checks if A is less than B, put A first, like swap A and B. That means putting A first and B later. But here, in case of 3 and 30, and here we need in descending. So I would say, do my 30 is greater than, let's say it is 3. Okay, let's say it is 3 only. Do my 3 is greater than 30? It's not. So we will actually swap. We will put 30 first and we will put 3 here. But this thing we don't want. We actually want the higher result. 3 and 30. Putting 30 first and 3 later is not doing our job fully. What we need to do, we need to perform a concatenation at the end. It means we need to add these all. So why I do not do something in that order only. So when I have 3 and 30, I will check. If I concatenate 3 and 30 together, what I am getting? 330. And if I'm concatenating 30 and 3, like A and B, A plus B and B plus A. If I concatenating A plus B together and B plus A, which one yield me greater result? Here, 330 is yielding me greater result and 303 is yielding me lesser result. That means if I have put my 3 first, it would be a better choice. But a simple sort, which only comparison on the basis of less than or equal to, would do not do this job. It can only give us 33 or 330. If I'm talking about increasing, if I talk about decreasing, we can only get this. But what we need can do A plus B is yielding me a greater result or B plus A, because we can easily see 30 and 3. 30 and 3 would give me 303 and putting 3 give me 330. So putting 3 at first would be better. But a a knife sort cannot do. So we actually need to modify our sort. And that's why we want to know what is actually the custom comparator and what is how we make a custom comparator in our sort. For this, let me explain you how custom comparator actually works. This is actually I make a sort function here, and this is nothing just like a bubble sort and square solution. And I'm checking if this is greater than this, we just need to swap. This is very trivial, and you all know this. I'm very much sure. So we are getting 303. Actually, I don't know are you getting able to see it or not, but it is actually 303. But what we need something good. So we need to actually make this our logic good. So here I have already tell you, instead of, let's say, let's make string a as str's of I and string b as str's of j, and let's say now string f is a plus b and string s is equals to b plus a. Instead of checking this, we are checking if I check f greater than s and then swap, then I think I would be getting good result. STRs, I get an error. Okay, we know this one would never yield me a good result. But if I do check a plus b and b plus a, then I am getting, then I can swap. Like if this one is yielding me greater result, then swap ij, putting I first. So this is, I am getting 330. So actually we need to change our logic from simply a greater than b, a greater than b, to something like f greater than s. What if I say I have a function called can swap and I am passing str's of I and str's of j in it, can swap. And here, let's say I have a function named as bool can swap, in which I have a parameter, let's say string a, string and b. And if I write this thing here, and just return if f is greater than s, instead of this, if I write a and b, that would be good. Okay, instead of this, if I have something can swap, because actually we want to check this logic only when we need to perform swap. So we need to perform swap. Okay, this is getting us good result. We need to first perform swap if a plus b is yielding us better result than b plus a. Actually, we need to change this can swap method in our actual sort method that we are providing in the STL library. So that is, I think this much is clear. We need to change this. And now the thing is how we change. And here comes the custom comparator sort. So instead of sort, this is my actual function actually. You know, when we do strs.begin, strs.end, it's do the same thing. Let's do the same thing. 459. This is general. 330. This is giving me in ascending lexical order. But what if I just pass a can swap method, which is my custom? This will make this a custom comparable sort. Now you will see I am getting the result as expected. We wrote our own logic for this swap function. We wrote, now I don't need this. You can just take in this way that we make this can swap logic by our own. And to implement our own logic in the actual sort method, we actually pass a comparator, which is this can swap method. And this we wrote here, that what this actually do. And we know it actually yield us, it actually put a forward if a plus b is yielding better result. So this is how we make a custom comparable sort, by just passing a custom comparator, which is in this case is can swap, and the logic we tend to wrote here, we actually wrote here. This is like how we want the answer, in which way we want our answer in. So this is how we write a custom comparator. So I hope now you know how custom comparator internally works. Internally, it works the same way. This works the same way in our sort method also. But since we need to change this logic, we pass our own comparator. So this, the same function I will take here, the same function I will take and copy paste here. One more thing, we need to make it static here because we are actually making changes in our sort method. And in we have to write here in compilers, in online compilers. Internally, we don't need to write, but there we have to write because otherwise it will throw us an error. And here I will say sort arr.begin, arr.end. Simple sort method, but just sort in this way because we have actually changed the logic of this condition. This is the actual the logic, and this is nothing but our comparator, which is actually can swap here. You can also name it comparator any name. And again, we just can do auto and strs in my arr answer plus is equals to strs, and I can just return answer. Also, guys, I'm recording this video third time now because of like power cut issues. I hope this time this will wind up well. So you can see we are actually getting the right answer. We are actually getting the right answer, and I hope this should work fine. Yeah, this is the fifth attempt because I was making a video very long. So this thing, we can actually write our comparator function like this also, sort method. But instead making of a comparator function outside, we can use something called lambda function and write the same logic here only. You can do research, you can research for what is lambda function, but this is like a short form, like if we don't want to make our function outer. Okay, this condition greater than s should be there because if you put greater than equals to s, it is not actually because like let's say 88, and you might have checked for 88 and you because this was a greater and you tend to swap this. Okay, but the next time when you are checking for this 8, again this will perform swap operation with this 8. And let's say if this was something where anywhere, so let's say it was at I plus 1 index at some point and you make the change from here again, you put it at the right position, but next time when you perform swap for this also, you tend to put this in its right position, and let's say the position might get differ. You might not getting it, but let's say you have something 8 8 because what we do in sort, we tend to find it good position. So I you form it good position, let's say after this iteration, because you would have swapped this. But next time when I is come here, at this point you should not modify, you should not tend to change this position. But in this, because of this, the position might get affected. And what say if we have greater number after this, so it might have changed this, but next time this 10 would have changed this. So that's why if the result is higher, because if it is already in order, why we will bring it here? So if a plus b is yielding me better result, I would put a first. And if even though if it is 8 8, I will not bring this 8 here because might have this 8 which I will put here would have swapped by something else and may got me a wrong answer because we are just concerned. So I will remove this. We don't need this equals to. We are just concerned about is it greater in this code also, because just make swap, just make swap. If you find a plus b is yielding better result than b plus a, then we can just put a, and that is what we do in actual sort method also. If it is yielding me higher, and if it is not yielding, it is actually already in itself in order. So why would I should change that? So this same comparator function, I make you understand here what it's actually do. It is nothing but this method when to swap or when to perform operation in this actually when to perform swap. Here we perform swap if a plus b is yielding us greater result. This is the same thing. I would also add this logic also like in my GitHub repository for reference, but actually the same. Another way of writing comparator. Static, we write, we have to make function static here like in online compilers, otherwise it will give us error that method need to be static. It itself says that invalid use of non-static member function. So because we are changing actually the online library of where it is deployed, that's why we have to write it static, and rest things are all same. I hope you get the logic, you get what is comparator function, and you also get what actually the comparator functions do. So thank you, and not get this side.